Hello, dear students. I welcome you on our sixth lecture. So today I want to uh, remind you some uh, aspects about functions from last lecture, and want to talk about imports and working with files in Python. So I want to share my screen. Um, okay. Um, let's start with last lecture material. So we talked about functional programming. And I've said that the difference here is that we can think about it like we use functions inside functions as arguments. So foo1 is not a result of some function, but the function itself. And we try to see some examples um, using a map function. So once again, what maps do? It gets function f at use it our each element inside the second argument, which is iterable object. So it literally gets our iterable object, implement function f to each element, and return the special map object that can be conversed into the list. So let's create some examples. So assume we have a list of words. And we want to return in our function the length of each word and use it inside another list. So we want a list with lengths of the words inside the initial list. So of course we can do for we can create a new list or length list, and for each word in words list then list we will append with the length of the word. So it's a legit way to think about it, but this is imperative programming. And if you think functional, we can use a map function with a iterable object. So we can create our len list as a list where we'll have map object from function len that was evaluated our each element inside the words list. So let's check if it works. Yes, we have our length for each element inside the initial list. And of course, we know that in Python there is dynamical typization, and the function len can be implemented to each element that has ability to return its length. So, for example, we can have here a set that consists of 3 numbers. We can have here another list, nested list with 5 elements, or I do not know what else. I think that's enough. So we have string object, string object, string object, set object, and another list. So in Python, we will have, so what the problem? Set expect host arguments. Okay. The creation of set can be done like this. So 3 and 5 for our last objects. Or another way to create set, of course, is set function from, for example, tuple or another iterable. So please ask your questions if you have about the map function and how it works, because I don't know, do you understand or not? Okay, let's go to another good example of functional programming. This is a filter function. So I think we have talked about it last time too. Filter function. So filter. Once again, it has 2 arguments by default. So function f and iterable object. For each element in iterable object, it implements the function f, and if function f returns true, all okay. If function f return false, we get rid of this object. So we filter our iterable object with the condition of function f. So let's go to our example with a list of objects, and instead of using map, we will use a filter. So, and our function will be def function f object if len of the object is more than 3, then return true, else return false. So let's filter our words list with such function. So it will called filtered list. Pay attention to the naming convention. So please use clear to understand the variable names. It really helps you when you read your code after some time passed. So it returns the list that consists of 2 elements, the word 3 and nested list with 5 elements. All of other elements were filtered out because they have less or equal than 3 elements. So here we defined our filtration function. Okay, the next interesting thing is the anonymous function. So anonymous function, also called lambda function. Where we use it? We use anonymous function when we need this function only in place, only here and nothing else in our code. So for example, here we used filter function, and we defined this function f usually. So we have usual definition with def, function, arguments, and the body of the function. But in some cases, we want to use function only one time, and there is a special notation to create the function that will have no name, but we still can use it. For example, here inside the filter. So the syntax is like follow. So we use lambda, the word lambda. After that, we define our argument, for example, x. We have semicolon, and after that, we write the return expression. So, for example, x and x in square. So let's try to create lambda function like our filtering function here. So I will delete my filter function, and we will try to change this f to the definition of anonymous function. So actually, it's really simple when you understand how to work with anonymous functions. Just think about them like definition and execution of the function in the same time. So we use lambda. X is our element, so we can name it like element, for example. And what we want to return true if element, no, if length of the element is more than 3, else false. If you remember, we called this construction a ternary operator for the condition. So it will return if this condition is true, and this if this condition is false. Okay, let's try it. Invalid syntax. I forgot the letter D. Okay. And it works. Lambda functions are very useful in your scientific pipelines when you work with, for example, such libraries as pandas. You work with tables, with data frames, and you want to apply some functions to your data to somehow convert it or make minor changes inside your rows, or for example columns. So, and you want your function to be executed only once, and here it's really it's more easier to use anonymous functions, because instead of it you ought to implement it. So this is the same like f element and so on. So here we just get rid of definition and use the function in place. Okay, do you want some more examples about Lambda, or is it enough? Guys?
I think it will be good to have one more example.
Okay, maybe some questions why we need it. So what is not clear here? I know that this theme is not like intuitive. Okay, let's create another example. So in the another function, let's talk about function reduce. It's another function in functional programming style. So we have reduce function, reduce, and again we have function f, we have iterable object, and what we do here, we have our iterable. So the reduce gets two first elements, execute function f over them. After that, it gets the result of this execution as new element and gets the next element. And again and again and again, it implements f, taking one by one elements. So we execute f here, after that here, after that here. Let's create something that use reduce function. Do we want to work with strings? Actually, I do not know. Okay, let's imagine something interesting with strings. 3, 4, 5. How we can reduce them? We can concatenate in some clever way. let's create brackets between words. So let's create function f that gets two elements, x1 and x2, and it will return the string that is formatted in such way that we have brackets, and inside brackets we have x1, comma, x2. Okay, and reduced list. Not reduced list, because the reduce function will return not a list, it return object. So our result is not list. Okay, just our result will be reduce from reduce using function f our words list, and please print us the result. So how it will works? Where is my annotation panel? At first, it will take two arguments and execute function f with them, and we will have 1, 2, and this will be our result. After that, it will take the result and 3, so we will have 3. After that, it will have the result and 4, so it will be like this. Okay, let's try to check it. So I want to save this. Name reduce is not defined. It's very strange. Maybe this is a function from some library. Okay, I want to check it. Reduce. Okay, it's in the module calls functools, so it's not a problem. From functools, import reduce. Oh. And what we have? We have the same thing that I wanted, but of course it's not comma, it's an M. Because it was a typo. Now it's like I want. Let's go back to the lambda function and try to do the same using just lambda. Here we have a usual function with definition, but we can create a lambda function right here. So we have lambda, 2 arguments, x1, x2, and we will return the formatted string with x1, comma space, x2. Yes, it's the same. So we just get rid of the definition and we define the function and use it in place. This is really the same things. This and this. Please ask your questions.
I think it's clear.
Okay, because it's a special syntax for function definition that is really useful in the functional style. And in Python, we can't use functional style in our programming practice. So it's not just imperative style. It can be functional, and there are a lot of functional stuff in Python. And Lambda function is very useful when you do such things like here, when you just want to use this function one time and forgot about it. Forget. Okay. I think we can look at the zip function in such a way like we looked at reduce map and other things, because zip is another example of the functional programming. But here we have no function, we have just iterable one and iterable two. So we have one iterable and second iterable. And we use zip to combine them into pairs. Or maybe I want to use another color here. So zip will return a zipped pairs that consist of relative elements from the iterable one and iterable two. So maybe this graphical representation is much more understandable than the formal definitions of the zip function, because we really can think in notation or in way of thinking about iterable objects, how we work with them in functions. Okay, so I think that's all about functions from the last lecture, and we can go to the imports. Maybe here you have questions. No? Okay. So let's go to the imports. Here you already see that I import something from functools. Actually, functools is a very useful library that you can read about by yourself. A lot of useful functions there. But let's talk about imports and your own files, how they connected to each other, how we can use imports inside Python. I think that it be more productive if I will use Microsoft Code text editor here, because I want to create multiple files. So let's create a file called mymodule.py. Okay, this is a Python file, usual Python file, where I want to define some functions. But before, I want to print my I want to increase my font, but I forgot how to do it in, oh, okay, it's increased. My module was imported. And that's all. I want just to have these in the Python file. So, okay, I want to have another file. We call it my program. .py. And in my program, I want to import my module. The system that analyze our code in Microsoft Code already substitute for me all modules that I can import. So it's very useful if you work in such complex text editors or in IDE, for example, in PyCharm, they have the same features. So after that, I want just to print this is this is a code of my program. So I can run it. I want to run my program and see what it will print. Double. So look here. It prints my module was imported, and after that it prints the actual code of the my program file. So why we have such a result? We must understand how imports work in the Python, and it's really easy. So assume we have our main file with program, so program code. And we have some package or module file of files here. And when we import something, we literally insert all the text from this file into our original file. So imports works just like this. You can think about this just like this, but there are some exceptions. For example, I have already talked to you about constructions like this. If name is equal to main, please do something. I want to print my module.py was executed like a program. So this code will be executed only if we execute the module file itself, and it will never be executed if we import the module. So once again, we run the my program py. So this is my program and this is my module. In program we have import, and in return my module was imported. So only this code, and this code was not executed because the name variable here will be not main. Actually, we can print and see what it will be. Oh, we can do like this. My module was imported. Okay, another string, and its name variable is and what so I want to save it. Saved. So we have my module was imported and its name is my module. Okay, if we run it like a own program, my module.py. Okay. Actually, I was wrong. So it implements all the code here, but I just show you how it works with such construction. So it write that my module was imported and its name variable is main. So we run it like its own program, and the name variable now is main. So how can we divide these parts of code that this can be used only like in module and this like in when it is executed like on program. So usually here we have only definitions of our functions and classes, not executable code. So we can create a new function here. So this was if, and here I want to create the imported function that will print the same information like my module was imported. And another function executed that print my module file was executed. And under such construction, we will just execute the executed function. Actually, the good choice is used to name main. Once again, it's a very good choice to use main functions as entry point in your programs to be understood by other programmers, because the history of programming languages told that main function inside the program is an entry point, the function that starts the execution of the whole program. So maybe here I want to use main instead of executed. So now it looks like a standard construction for the module file. If name is equal to main, please execute the main function. Okay, let's go to the terminal. And if now we execute the module file, it will return my module file was executed. And if we execute program file, it will return that this is a code of, okay, I forgot to, after import, I want to use imported function here. So to use it, I must write here my module dot imported. So what we have here, we have execution of the function inside module. We use dot syntax for this. So for example, if we have random library, so this is a module that contains a lot of function that works with a random generator, we can use it with dot like the same. So randint, for example. So it will return for us random integer from 1 to 100. So this is just a dot definition. And let's check it. Okay, so my module was imported. This is a code of my program. So now it works. Let's try to find what different methods of importing we have. So not the methods, but how we can write this. So here we import the whole file. So once again, all the text from here will be copied to the beginning of our code. But we can import only functions, specific functions or objects from the modules. For example, we have function foo that has one, for example, string, and it converts this string in the fancy way, for example, like this: return S, return F. So it will add frames with asterisks to the string. Okay. And we can use our import in such way. We can write from my module, please import only function foo. Look here. We can't now use imported functions because we have no name my module. We have only name foo for the function that was imported. And of course, we can use it like this. Please print foo from we can do it like a functional way to repeat. So please print list of map of foo our without brackets foo and a list of words 1, 2, and 3. Okay, here we are. So I want to print the list of string objects where function foo will add a new fancy frames. So how it will work? Yes, it returns exactly what I wanted. We can use another thing. If our module has a really huge name, or if we have some convention that is common in the programming society, so we can create such things. Please import my module as special word and here we can use name like a module file, like a module name. So please .imported. It will execute imported function. And here we have no such name as foo, but we can access foo with .foo. And I want to save this. Let's try. Line module. My module has no attribute imported. Okay, I forgot the letter. Imported. Yes, it's worked. So we have first imported function. After that, we use the foo function in our map function, and all of this works. So what again we can use as imports? So we can use every name, every object inside the module. For this, we can write such expression. From my module, please import all. This asterisk means all. And we will have access to all names of objects inside my module. So we can use imported functions, we can use foo function. Okay, let's check it. Yes, it works. The thing is where we can find our modules. So as you can see, our program and our model file, they all lie in the same directory. But assume if we have another directory, my dir, for example, and our module.py will be in the my dir or in another folder. So we have no my module here. And we try to execute the same code. We have an error. We have an error that there is no module named my module, because the Python interpreter do not know where exactly our mymodule.py is, where it can find it. And here we can do another things. So first of all, let's introduce module sys. This is a module to work with our operating system. So in sys we have I want to comment this. In sys we have special variable sys.path. Let's look what it has inside. So this is a list of different paths of different folders where Python interpreter looks for the modules. So first folder is the current folder where is the executed file. So my program is inside the lesson 6 folder. And this is the first path where interpreter want to find the mymodule.py. After that goes the standard library directories. These all are standard library directories, so you can think about them as this. And the last thing is our installed packages. So use pip program or other things like wheel, we install some new modules to our Python. For example, NumPy, Pandas, etc. So all our side packages are here and here. Okay. So in these two folders. And in this folder. Okay. So nonetheless, all these directories are already in our system path where interpreter will try to find the module that we want to import. But there is no folder my directory here. And of course, interpreter can't find our module. How to do it? The bad way to do it is syspath.append. So we just add a new path here. So this is a string and paste my dir. So this is a bad way because we do it inside the script. But okay, after this, we can import, we can use our functions. So let's check it. List object has no, okay, append, of course, append. Another typo. So now it works because our sys path has additionally my dir. but it's not a good way because we use it inside the script, but we want to use it outside of the Python script. So there is a system variable. So I think that in Linux course, you must to know what is system variables, how we can access them, and how we can change them. So there is a system variable in Linux and in Windows too. So it calls Python path. Python path, no. Why not works? Not working. Python path. Why can't echo this? I just want to Google. Maybe I'm wrong with the name of the. So. Okay, it will add it when Python interpreter starts. Okay, so it not started yet. But we still can export it. Okay, so this system variable will be exist only when interpreter will start. But we can change it before this using export command, or in Windows using the change of the system variables inside PowerShell or inside the special control panels. So in Linux is really easy to do it. So we want to export Python path to be the same as Python path plus new folder, and our new folder is like this. Oh. Without any okay, and after that we can get rid of this string and try to execute our program. So yes, it works because with this string export Python path equal to the name of the variable Python path, semicolon, new directory. So we actually add a new directory to the Python path variable inside our system. And the Python interpreter will know where to find my module.py. But here we can see that Microsoft Code can't find my module to lint it, and could not be resolved in Pylance. Okay, so to be clear, we must configure the MS Code that it will be know where to find my modules. Okay, how else we can use modules? So when we talk about modules, we talk about code that was written by other guys. Look here, we can import anti-gravity. And you can do it too, because it's in standard library. Anti-gravity, okay. And what will be when I execute my program? It will open my browser on the XKCD comics with beautiful comics about Python. And yes, it works from some version of Python 3. So it's really interesting, but we want to know how it works. Inside good text editors and IDEs, we can use the names of the imports and names of functions to go there. So I can click my Control key and using mouse go to the antigravity.py. So this is an actual module of the actual module inside Python standard library. So what we see here, it has two imports. It imports web browser module and hashlib module. After that, it calls open function from web browser and use URL of the comics inside. So for example, we can change the URL here. For example, to load 355th comics, and of course it will work. So we change the module inside our library. So, and when we try to execute it once again, okay, we can't change because maybe we have no rights, but I'm not sure. But okay, in usual case, it's not a problem. So why is the problem here? Yes, permission denied access to anti-gravity. So this is my system installed Python interpreter, and to change the internal files in the standard library, in the interpreter code and other things, you must have a root access rights. So you can use your sudo, but it's very dangerous. You can broke your system interpreter. But of course, you can have a virtual environment with Python and change even a standard library function. Okay, so I have talked about useful features of the text editors and IDEs. So we can, for example, import NumPy as NP. And after that, use NP array from NP zeros to matrix is equal print. So assume that we know nothing about NumPy. Why not zeros? Ah, okay, zeros. Okay. Got the syntax. So we must need a tuple here that is for dimensions. Actually, look here, when I write something inside the function, text editor, Microsoft Code tried to help me, and it write that here I want to have a shape of matrix and other things. So it helps me using the documentation for the library. So what I will have here. And P0s returns a matrix 2 by 2 consists of zeros. But assume that we're not interested in NumPy functions. We just want to see how it's implemented. So using control, we can go to the definition of this function. So here we have def zeros, shape, type. So long. Okay. So this is a doc string that was shown. It was shown when I tried to type. And this is a special symbol to. So the thing is that NumPy functions is implemented in C, so in language C, and it's a better example to show you how we can go to the definitions. Maybe we can use import random. And random choice, for example, choice from 1, 2, 3. Okay, and if we go to the choice functions, okay, this is a definition in Python of what choice is. It returns sequence self run below. So you can read the code that you're interested in. You can go to the definitions of each object, of each functions you're interested in that was imported from other files. But this is a feature of text editors and IDEs. So of course, we can do it in console, like in Vim, but it need to be installed some plugins, a lot of configuration to do this. Okay, I think that's all about importing modules. If you have questions, please ask. Because
could you please clarify difference of execution my module py before import and after that?
Once again, so the difference is not before or after import. The difference is what file we execute in our console. So I return back to the previous state. The difference is that I execute here Python my module .py. Actually, now it is in another directory. And here, only this code will be, no, the all code will be implemented, but this is just the definitions of functions. They will not be executed. Executed will be only this part of code, so only main functions. And we have only my module file executed text, so only this. The another situation is when we execute my program .py. So this is my program. And of course, it's do not know about my module because once again, I need to export Python path. Okay, now it knows. Okay, all the text of my module goes here. No, not the text. Here we have asterisk. So all functions, all function definitions from here goes to the beginning of my program code. And we can access them inside our code. And this will not be copied because this is construction special for running this code only if module was executed like a program by itself. Okay.
Okay, thank you. But I just remember the case when we use my module py, and the name was my module. And when we executed the file after import, the name was main. I want to
okay. So this is a special variable that characterize the name of this piece of code. When we execute it like a program, so when we execute a file, mymodule.py, this variable will be main, like this. And if we import this piece of code to the another file and another program, this variable will be a name of import. Okay.
Okay, thank you.
So it depends of how we access to this code. So we access the directory by executing, or we access it by importing. Guys, I have too little time for files. I wanted to show you how to work with files. Maybe I start, but only 14 minutes. Okay, let's start. So files. Have you heard on your Linux classes about file descriptors? So it's not so important, but to understand that we have files in our operating system in file system, and they can be opened, and our thread or our process can have access to the file, and we call that, we open file descriptor to write or to read file. So in Python, we have the same things. First of all, if we want to read something from file, no, not about reading. So if we want to open some file, we must create an object using open command. And here we have file name and the descriptor how we want to work with them. So we have different types. This is for writing to file. This is to append. The append is writing to the end, because W is just override your file. We have R to read file only, read only. We have R+, this is not so common, so it's read write access. Okay, and we have read binary to read file as binary stream. Read binary. Okay, I think in practice it will be much clearer. Actually, I want to have test. I have downloaded actually the full text of War and Peace in English by Leo Tolstoy and wanted to somehow work with this. Let's do something really quick. So our file will be open leo.txt. Of course, it's a string argument. Let's open it to read. And for files, for file object, if you open them in such way, do not forget to close it, because without closing the files, we can have leaks in system, we can have errors, a lot of bad things can be if we do not close our files after opening. So, and we can read some lines. For example, the most common way is to use file object like an iterable, where each monomer of iterable will be a string before new line. So we can use for line in file. This is just the name of the variable we have. We can have X here or L here. I prefer to use English for line. In file, please print line. So I can use enumerate here, and for indices, if E is equal 100, please break. So I just want to print the first 100 lines from War and Peace. Unexpected ident. Where? Ah, okay, here. And I need to fix the end of the print function because we have two new line symbols. One is from original text and the second, actually we can use a strip function that get rid of the new line symbol in the line. Very useful function to work with files. So this is a beginning of the War and Peace by Leo Tolstoy. So we have an access to the file. How we can read it in other ways. So for example, we can create so we have our file opened. We have create a variable content and it will be equal to the file dot read. So please print len of the content. So it's 3 million and a little bit more symbols. Maybe we can access using slicing the really beginning of the content. So please show us why we want beginning. Maybe from 10,000 to 10,100. And here we have strings from the book. Okay, how many such functions we have? We have file dot read to read all the content of the file inside some variable. We have function readLines that return the list of lines inside the file. All of lines in file will be stored in list and will be returned as a list. And we have a function readLine without s. It will return one line from the file and change the pointer inside the iterable. And if we use it second time, it will return the next line, so the second line. Actually, I want to use a good example here, but it takes much more time. So maybe I will talk about it next time. So I think I have no time for additional material, and we have 3 minutes for your questions if you have.
How can we display the columns from TSV file?
What do you want to get only one column from TSV, or what?
Yeah, I want to count how many zeros I have in column and how many ones I have in column.
Okay. So when you talk about tabular data, please think about using the special packages like pandas, because it's very useful. You can use your TSV files to store your data, and in pandas you can read them into the data frame objects. And with data frames you can do whatever you want. You can count zeros in column, in rows. You can apply functions to the columns and rows and so on. So please read about pandas library, and of course you will have pandas in the scientific Python course next semester.
Okay, thanks.
So the library calls pandas, and usually it imports like import pandas as PD. Okay. A few words about the name and shortening and conventions. There is so in community we have standard names. So PD is for pandas. For NumPy we use NP. Actually I forgot. For SciPy we use SP, and so on. Please, if you see the standard shortening of the library, use them, because another people can understand you. And actually, I prefer that you do not want to shorten your own libraries, because it is not so good for understanding what you mean when you shorten it. My very good library into MVGL. So here in long names, you can have some sense what you want to do. So DNA processing classes. This is a very good name for your library. And if you want not to use this long name in your code, you always can import. You can, from DNA processing classes, import special functions or all functions or all classes. So I insist maybe that long names are better in the user-defined libraries. But of course, we have shortening for the packages that is common in the community. Okay, 51 minutes, so I think we can finish if you have no question. Thank you, guys.
Thank you.
Thank you. Goodbye.
Oh, goodbye.
Thank you. Bye.
Thank you.
Thank you.
Goodbye.
Thank you. Goodbye.